Hi, welcome back. Can you believe it? It's our last lesson in our second unit in AP Calculus. This lesson is all about derivatives with data. When necessary, we will use calculators, but I really want to emphasize that on questions like this on the AP exam, free response questions, it's not about the arithmetic, it's not about the number, it's about the calculus, it's about the justification, it's about your writing and explanations, and units. So let's dive right in. I want you to do each problem before I do it, each part, one at a time, and then we'll go over it. I might not remember to tell you to pause the video, but you do so and go on to the next part. Let's read it together. Water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function w for 0 less than or equal to t less than or equal to 24, where t is measured in hours and w of t is measured in gallons. Values of w of t as selected times t are shown in the table. What I'd like you to do is to do part A, use correct units, and explain what it means. Give it a shot. Okay, so here's how I would answer part A. I would simply say that w of 8 is 221. I got it right from the table. There's 8 hours. W of 8 would be 221. So 221 gallons is the correct units. And now I'm going to explain my answer. At t equals 8 hours, the tank has 221 gallons in it. If the AP test does not ask you to put units anyway. If they remind you, great. If they don't, put units. Sometimes they'll give you problems where they're just, even though it's a problem you'd expect there be units, there won't be units, in which case you don't need to put it because they didn't give you any. But usually you need them. And when they ask you to explain what it means in terms of the situation. Okay, I want you now to evaluate W to the negative 1. What does that mean? That means W inverse of 184. Do the work. Okay, W inverse of 184 is asking what t value gives you a W value of 184. Well, that's 4. So the answer is 4. What is the units? 4 hours, because it's an inverse. So my units are, you could probably say just exactly the same way. You could try and write it in an inversey kind of way. You could say it took 4 hours to have 184 gallons, but I'll just say at t equals 4 hours, there is 184 gallons in the tank. All right, let's go down to the next one. I want you to approximate W prime of 15. Show the work that leads to your answer, use correct units, and explain the meaning of the value. But give it your best shot. But remember that when they tell you to find W prime of 15, you need to choose table values as close to it as you can. Okay, so this is how I would calculate W prime of 15. I can only approximate it. And although they don't require it, I think it's a good idea when approximating to use the approximate symbol, not the equal symbol. So I'm going to have to use the slope of a secant line or an average rate of change. And I want to use t values that surround the value that they're asking. So I'm going to use this. If they ask you to approximate a derivative at a value that's in the table, then you should use that value and either the value 1 to the right or 1 to the left. And it's your choice. You can use either one. But if they give you a value like 15 that's not on the table, you absolutely must use the two values that surround it. So I'll be using those two. I will say W of 16 minus W of 12 all over 16 minus 12. I like you taking the second to write that step down. That is not going to be enough to get us credit, though, because we have to evaluate. But I want you getting that idea that the average rate of change is f of x2 minus f of x1 over x2 minus x1. So now I'm going to replace the 16 with what it is. W of 16 is 294. W of 12 is 257. All over 16 minus 12. And now I need the units. The units on this is rate of change. W of 16, W of something is gallons. 16 minus 12 is time. So we have gallons on top, hours on bottom. That's exactly what we're going to do. You can, to get this units correct, when you do an average rate of change, just simply put the units from on top over the units from on bottom. Notice I'm not actually typing this in my calculator and evaluate it. If you want to evaluate on your calculator, fine. But there's no reason to write it down. And during the AP exam, you really shouldn't. The only time you have to evaluate is to get a multiple choice answer. But you get full credit. You can't leave it in terms of W16, but you get full credit when you plug this in. Even if you have a calculator, let's say you mess up. Maybe you forget to put the top in parentheses and the bottom in parentheses, and you end up only dividing part of the numbers. It's just not worth the risk. Don't do it. Leave it like this. Now, we do need to explain the meaning. So I'll just say, this is the rate of change of gallons at, what is it, 15 hours. This is the rate of change of the gallons at 15 hours. Not, well, you know, let's not say of gallons. Let's say rate of change of water. And if you want to say rate of change of water in gallons per hour, fine, but we already put it right there. But that's what you say every time. If they ask you, what does this mean? The derivative. What is the derivative? It is the rate of change of W. What is W? Water. Rate of change of water at 15 hours. Okay, next. Find the average rate of change over 4 hours less than T, less than or equal to 20 hours. Show your work, use correct units. Go. All right, and we're back, right? If you don't mind, I want to have this table available to me to look at. So I'm going to go ahead and remove this. Pause the video if you still need it, but I'm going to take that out. And I'm going to move this up so that I can look at my table of values a little bit more easily. So, rate of change, average rate of change. The average rate of change is exactly what we just used to calculate the derivative. We weren't calculating the exact derivative, right? We need the equation for that, but we could estimate it. Well, this is what we're basically doing the same thing, but we're getting an average rate of change from hour 4 to hour 20. So it's going to be W of 20 minus W of 4 all over 20 minus 4. W of 20 is 327. W of 4 is 184 all over 20 minus 4. And that is gallons per hour, because we're using the W of 20, that's gallons, over 20, which is an hour. So it's gallons per hour. Okay, what does that mean? The average change in water over 4 less than or equal to T less than or equal to 20 is, you know, this value. I can write it again, I guess. That's the meaning of my answer. I probably wouldn't have had to write that expression if I just said, this is the average rate of change in water. Sorry, that's so hard to read. The average change in water over that time period. Okay, so let's try another one. Let me get rid of this now. All right, so you try E, and then we will discuss our answers. Okay, so for 0 less than T less than 24, must there be a time when the tank contains exactly 265 gallons of water? Okay, so if I look at the table, there were 257 gallons of water at hour 12 and 294 at hour 16. So must there have been a time? Absolutely. So let's do the work properly. We're going to say, and I'll just use the 0 and 24 since those are the values it gave me. I will say W WT is a continuous function. But that's not enough. I got to say how I know. They didn't say it was a continuous function in the problem, did they? I'm making a conclusion, so I need to explain how I know it. How do I know that W of t is continuous? Because W of t is differentiable. Differentiable is more rigorous than continuous. Now, that's the most important part of the problem. I mean, I could take it probably to a freshman in high school and say, hey, I got this table of values. Do you think it ever hit 265? Be like, yeah, of course they did. Yeah, it's right there in between 12 and 6. I mean, that's obvious, right? But would they have known how to justify it properly, mathematically, by establishing continuity from the derivative? I don't think so. So that's what they're testing. And if you don't put that, you're just not going to get any points. Okay, next we need to establish that W of 0 is less than, in this case. We just need to establish that 265 is in between these two values. And if for some reason they weren't, like if it had gone back down, I would have to pick a different value somewhere in this table, one above, one and below. But in this case, it seems to be increasing, so it's fine. So then I have to cite it. Therefore, by the IVT, W of t must equal, excuse me, must equal 265 gallons at some point for some t 0 less than t less than 24. That's that open interval that guarantees it on. Okay. Most all graphing calculators have an ability to approximate the derivative value. So that's really important. It's one of the required things on the AP Calculus exam. Everyone must have a calculator that can solve for the intersection of two graphs, estimate a 0, and must be able to take a numeric derivative as well as a numeric integral. So we have to be able to do this, and it's a shame that we're not necessarily practicing with our calculators when we're at home right now, or if you're at school, good. But make sure you figure out a way to do this. But again, I will use the Desmos calculator for this step here. We are given a equation. I need to calculate the derivative, and I will do that, a numeric derivative, just like this. And it's, it is a shame that I'm having to use a different calculator right now than you will, but it's pretty much the same. It really is. So I'm going to go in here, and I'll just go to graphing calculator, and I'm going to type it in. So I've got, I bet you it'll even let me do A of t. Let's find out. A of t is 1 over 225 times negative t cubed plus 30t squared plus 1800t plus 33750, close parenthesis. All right, I want to get A prime of 15. And the answer is 9. And that's all there is to it. You type in the function, you do A prime of it. So 9, what's the units? Gallons per hour. They didn't ask me for units, but it doesn't matter. I'm going to give them units if they gave me units to the problem every time. Now let's find the average rate of change of A of t, not using the table, but using the expression. So how are we going to do that? Well, we're going to write it down. We're going to say the average rate of change is equal to A of 24 minus A of 0 over 24 minus 0. We can't leave it like that. We've got to figure out what A of 24 is. So let's figure out what A of 24 is. You don't have to do a lot of calculating, but you can't leave it in that function statement there. You gotta take it further. So I've got 3, and they really should be 3 decimals. I'm not sure if I'm really getting that full value. It looks like I am though. 357.36. Minus, I need what? A is 0. 150. All over 24 minus 0. And that is in gallons per hour. And I am not going to go any further than that. I don't need to. I don't have it in function notation. I'm done. You want to figure out what that is just for your own interest, to figure out what the average rate of change is, you can kind of, you can type it in, but just don't write it down. It's not worth it. What if you typed it in wrong? So that's it. That's the end of this unit. Aren't you excited? I can't wait to start a new unit with you. So you've got some practicing to do, I'm sure. But until I see you again, take care.